Hello students, in our previous class we had a discussion about differentiability. So how to differentiate when we have composite functions, that is exercise number 5.2. A function in another function means is nothing but composite function. How to differentiate the composite function and all we have seen in our previous class. Now there is another problem in exercise number 5.2, that is question number 9. Prove that the function f given by f of x is equal to modulus of x minus 1, x belongs to R means real numbers, is not differentiable at x is equal to 1. Is not differentiable at x is equal to 1. So how can we show that it is a different problem? When we are discussing about the concept of differentiability and the concept of derivatives, differentiable means we know the process of derivative. The process of finding the derivative is nothing but called differentiable. Derivative. So how to find the derivative of a function? We have a formula there. Limit h tends to 0, f of c plus h minus f of c by h. It is a derivative at c, at the point c, means usually the first principle of differentiation or the first principle of derivative we have f dash of x is equal to limit h tends to 0, f of x plus h minus f of x by h. This is the first principle derivative formula. Now here I want f dash of x function at x is equal to c, means we have limit h tends to 0, f of c plus h minus f of c by h. This is the formula for us. So this is the first principle of derivative, means the derivation of the function f at x is equal to c point. And we have discussed and we know that what we know, derivative exists. Derivative exists only when limit exists. Here, when limit exists, then only the differential means the derivative exists. If the limit gets failed, then there is no question of derivative. There is an interval between the derivative as well as the limit. So, when limit exists at x is equal to c point, then we have the derivative. So, using that concept, now we are going to solve this problem. They asked that not differentiable at x is equal to 1. Not differentiable at x is equal to 1 means that, now if I show that limit does not exist at x is equal to 1, limit does not exist at x is equal to 1, it gives us the meaning derivative also not exists. Once limits get fails, then automatic differentiation also get fails. When limit does not exist at x is equal to 1, which means that differentiable also not exist at x is equal to 1. So now I am going to show that limit does not exist at x is equal to 1. So that is clear for us. Now what we have to do? We have a clarity. So now we are going to show that limit does not exist. How can we say that limit does not exist? How can we say that limit does not exist? As again we have where the left hand limit, for example 0 minus, here we are talking about 1. So limit x tends to 1 minus f of x is not equal to limit x tends to 1 plus f of x. Means that the left hand limit and right hand limit both are not equal. When the left and right hand limits are not equal, means that limit does not exist. So when the limit exists also, we know that and all we have seen in our first exercise. Many problems we have solved finding the limits and continuity. So limit in the sense where the left and right hand limits are same, there the limit exists. Where the left and right hand limits are not equal, their limit does not exist. So now first we are going to find left hand limit, then right hand limit. Finally we are going to show that these two are not equal. When these two are not equal, limit does not exist. When limit does not exist, automatically the function is not differentiable and x is equal to 1. So this is the concept we are going to do here. So let us consider here what I am going to do here. First I am finding the left hand limit and also right hand limit. Then finally I am going to check it. So before discussing left and right hand limit, let us observe the function. What is the function given for us? They have given modulus function. So modulus function we have some definition. Modulus function definition we know. For example, f of x is equal to x when x greater than 0, means when the modulus x function we are discussing, f of x greater than 0 and minus x less than 0, 0 when x is equal to 0. This is about modulus function. So modulus, what is the modulus function importance? It gives negative value into positive, means it always represents positive value, which is also called absolute value. So when x is greater than 0, you have plus x. When x is less than 0, you have minus x. Why? X already negative. So negative of negative gives us positive. That's why we are taking minus x. When 0 means x is equal to 0. This we have to know very carefully. Now using that concept, let us come here. Let us continue how to solve this problem. Given that f of x is equal to modulus of x minus 1, where x belongs to R. We know that derivative of f of x at the point x is equal to c is f dash of x is equal to limit h tends to 0 f of c plus h minus f of c by h. So this is the formula we know. Now at x is equal to c, now we are taking at x is equal to 1. Just c is replaced by 1, and here we are going to calculate left hand limit and also the right hand limit, because as I told you, when limit exists, derivative exists. When limit does not exist, derivative is also not possible. Here I want to show that differentiable is not possible at x is equal to 1. So that now I want to show that limit does not exist. For that, I am finding the left hand limit as well as the right hand limit. Now let us see here. Now limit h tends to 0 minus left hand limit I know f of c. What is the value of c? 1. So 1 plus h minus f of 1 by h, that is equal to limit h tends to 0, h tends to 0. F of 1 plus h. What is the meaning of f of 1 plus h? Actually, f of x is nothing but x minus 1. Now, in place of x, what we have here? 1 plus h. So, what we have here? Modulus of 1 plus h minus 1 minus, again, in place of x, what we have? 1. In place of x, what we have? 1. So, f of 1. F of 1 means what we will have? Modulus of 1 minus 1 by h. That implies limit h tends to 0 minus, here plus 1 and minus 1 can be cancelled. We have modulus of h. 1 minus 1 is 0. Modulus of 0 is 0 by h we have. And here h tends to 0 minus. H tends to 0 minus means h less than 0. As I told you the definition of modulus of function. X less than 0, then modulus of x becomes minus x. When h less than 0, then modulus of h becomes minus h. So, we have limit h tends to 0 minus h by h can get cancelled. We have limit h tends to 0 minus 1. Finally, we have the value minus 1. So, this is our formula. This is our formula. Now we are finding the left hand limit. Limit h tends to 0 minus. 0 minus means left hand limit. And at x is equal to 1. So the value c is replaced by with 1. F dash f of 1 plus h minus f of 1 by h. Limit h tends to 0 minus. F of x is modulus of x minus 1. F of 1 plus h. In place of x, I have 1 plus h, so that 1 plus h minus 1 minus f of 1. So modulus of 1 minus 1. Plus 1 minus 1 can get cancelled. 1 minus 1 is 0. Modulus of 0 is 0. So modulus of h by h. H less than 0. H less than 0 means modulus of h comes for us minus h. So h can get cancelled, minus 1, and finally the left hand limit we have minus 1. Now let us find the right hand limit. Now I am finding the right hand limit. Let us find for the right hand limit. So limit h tends to 0 plus f of 1 plus h minus f of 1 by h. That is equal to limit h tends to 0 plus, again modulus of 1 plus h minus 1 minus modulus of 1 minus 1 by h. So here I have limit h tends to 0 plus 1 minus 1 cancel, 1 minus 1 also cancel. We have modulus of h by h. H 0 plus right hand limit. Right hand limit in the sense h greater than 0. When x greater than 0, modulus of x is how much? X. When h greater than 0, modulus of h is also nothing but h only. So, limit h tends to 0, h by h can get cancelled. We have limit h tends to 0, 1. Finally, we have 1. So, here the right hand limit what we have? 1. Previously left hand limit value we got minus 1. Now right hand limit value we got plus 1. Now when left hand limit and right hand limit both are different, when left hand limit and right hand limit values both are different means limit does not exist. What we can say? Therefore, limit h tends to 0 minus f of 1 plus h minus f of 1 by h is not equal to limit h tends to 0 plus f of 1 plus h minus f of 1 by h. So here the left hand limit and right hand limit both are different. That is, limit does not exist at the point x is equal to 1. When limit does not exist at the point x is equal to 1, therefore f of x is not differentiable at x is equal to 1. So the differentiable is possible only when the limit exists. When the limit exists, when the left hand limit and right hand limit both are equal. Here the left and right hand limits are different, so the limit does not exist. When the limit does not exist, differentiable is also not possible. This is about problem number 9. Similarly, we have problem number 10 that you can try it once. Now we are going to discuss another new model of the differentiation. So far, we have seen the function where we have one variable, means only the variable we have x. So when the function is having the variable x, we are supposed to differentiate with respect to x only. That is nothing but called explicit. Now we have a function with more than one variable, means you may have 2 variables or you may have 3 variables, any number of variables. Since just in this present exercise number 5.3, we are going to have only 2 variables. When we have 2 different variables, how to differentiate that kind of function, that we are going to learn. This entire process is nothing but called implicit functions. Implicit means that, so a function is containing more than one variable. For example, in exercise 5.2, we have seen many problems. We have discussed many problems. For example, f of x is equal to sin x cube. Now f of x is equal to modulus of x minus 1. F of x is equal to tan x square, etc. When we observe all these functions, we have one variable. We have only how many variables? One variable. What is a variable? X is the variable, and we are differentiating x with respect to x only. The variable x we are differentiating with respect to x. This is the model we know till now. Now we are going to discuss another new concept of that. For example, f of x is equal to x minus or x plus y. F of x is equal to sin x minus cos y square. F of x is equal to x square into y. Like that, we have 2 variable functions. 2 variable functions. So what are the variables we have? We have the variables x and y. Now, when we have the variable x, we are differentiating with respect to x. When we have 2 variables, x and y, how to differentiate with respect to what? With respect to what? Usually, we differentiate the function with respect to x only. Here, x we are going to differentiate with respect to x. Y is also we are differentiating with respect to x only. Means that when y we are differentiating differentiating, you will have dy by dx. dy by dx. This is nothing but y dash. So here y is the variable. The variable y or the function y, we are differentiating with respect to the variable x. When we differentiate with respect to x, we have dy by dx, which is nothing but called y dash. Which is nothing but called y dash. This model now we are going to discuss. This procedure is nothing but called differentiation of implicit functions. Differentiation of implicit function. Now let us see how to differentiate such kind of implicit functions we discuss today. That is exercise number 5.3. Here we have example number 24. What they asked, they did not mention implicit function or explicit function, nothing. Simply there is a question, find dy by dx if x minus y is equal to pi. Now this is the function we have. When we observe this function, we have x and y are two variables. Then what about pi? As we know that pi is nothing but constant. So x minus y is equal to pi. By differentiating this entire function, we need to find the dy by dx. Let us see a simple problem. Solution. Given that what is given, x minus y is equal to pi, make y as the subject, so that we have x minus pi. Now differentiate with respect to x on both sides. Now I am going to differentiate this entire function with respect to x. Let us see. That is dy by dx is equal to dy by dx of x minus pi. That implies dy by dx of x minus dy by dx of pi. So this differentiation function is applicable for both x and pi. Here y is another different variable, so we can't simplify. We have to write as dy by dx. That implies dy by dx is equal to, when x if you differentiate, the value is nothing but 1. When constant if you differentiate, the answer is 0. As we know that derivative of every constant is always 0. When x if you differentiate with respect to x, your answer is 1. So dy by dx is equal to 1 minus 0. That implies dy by dx is equal to 1. So they asked you to find dy by dx. Now what is the dy by dx value? We have 1. So this is about differentiating implicit function. Means if there is a function having more than one variable, means two variables or three variables. Here I have only two variables and they asked you to find dy by dx. So dx, you have to observe the denominator. So with respect to x we are going to differentiate. So differentiate with respect to x on both sides. By differentiating we have the answer 1. This is about example number 24. Now we have example number 25. What is given example number 25? Find dy by dx. Here also we need to find dy by dx. Means we are going to differentiate with respect to the variable x. So to find dy by dx, they have given a function. What is given? Y plus sin y is equal to cos x. Y plus sin y is equal to cos x. When we observe here, in this function also we have two variables. What are they? X is a variable and y is another variable. variable. So two variables are there. Now which function it is? Implicit function. Now let us differentiate here. So given that y plus sin y is equal to cos x. Here also differentiate with respect to x on both sides. Differentiate with respect to x on both sides. That is d by dx of y plus sin y is equal to d by dx of cos x. That implies d by dx of y plus d by dx of sin y d by dx of cos x. Now let us see how to differentiate. D by dx of y is nothing but dy by dx. Now d by dx of sin y. Leave about the variable y. What is the trigonometric function we have? Sine. What is the sine derivative? Cos. That we know. So d by dx of sine is nothing but cos y. But in place of x, what is the variable we have? Y. So that you have dy by dx. Dy by dx. Usually sin x is cos x. But here sin y is getting cos y. But in place of x, what we have the variable? Y. So you have to differentiate y also. It is just like composite function. So when we differentiate y, what we have? Dy by dx. Now coming to here, cos. What is the derivative of cos? Minus sine. So d by dx of cos x is nothing but minus sin x. Now from these two, I can take dy by dx is common. So when dy by dx is taken common, I have 1 plus cos y is equal to minus sin x. That implies they ask you to find only dy by dx. So here 1 plus cos y is multiplied, comes this side, divides. So I have minus sin x by 1 plus cos y. This is nothing but dy by dx. So differentiating every step is very important here. So this is how we can differentiate a function having more than one variable, means when we have two variables x and y. So based on these, in exercise 5.3 we have 8 problems. So let us finish those 8 problems. In our next class, we try to differentiate the inverse trigonometric functions. We know how to differentiate sin x, cos x, tan x. Now how to differentiate sin inverse of x, cos inverse of x, tan inverse of x, that and all we see in our next class. Hari Om. Thank you.